So go to 114, please. You finished it yesterday at like 1:45 and started playing Wordle, so I think you're good.
Actually, I didn't play Wordle. I gave a one-woman show.
Co-Wordle.
I didn't even play Wordle yesterday.
Whatever. No, it's not. Okay. So we started to talk about vertical asymptotes, but we're going to get like a little more in depth here. Tomorrow is horizontal asymptotes, which I was just like a day off. I don't know why that keeps happening, but if you remember, we had three types of discontinuities. There was a removable, which you get 0 over 0, and it's a hole in the graph. There was jump, which is like the piecewises don't match up. So yeah, pieces don't match. This is already in your notes. Pieces don't meet. And then there was vertical asymptotes, which we said was something on top of side 0 over 0. And then remember, these two are non-removable. So we're getting, yesterday we focused, or 2 days ago we did the jump one, a lot of those. Yesterday we focused on how to remove discontinuities, and today we get more into vertical asymptotes. So to start, and everyone does this differently, but you're doing that thing where you either set the bottom equal to 0 or factor. I'm curious how many do. So how many of you would do this and then solve it? And so I'd get like x equals -4, x equals 3. And then I'd plug back in. And if I get 0 on top, what do I have? Removable discontinuity. And if I don't get 0, what do I have? I have vertical asymptote. How many of you do it this way?
What's the other way?
Where you factor and start canceling.
I forgot.
You do the factor one, I guess? So the other way would be, I go, okay, that's x plus 4, x minus 2, and that's x plus 4, x minus 3. And so if the factors cancel, the solution from that is, and what is that? Removable discontinuity. So I have a removable, and it's not asking me this, but I have a rem disk at x equals -4. And then the factor on the bottom that doesn't cancel, the solution from that is the vertical asymptote. So I have a vertical asymptote at x equals 3. So how many do it that way, where you factor and like cancel-ish type thing? Okay. Anybody do it the other way? Like mix it up?
Aren't they essentially the same way, though?
Yeah. I mean, yeah, it's the same thing. It's just, okay. Okay. So now this gets a little bit goofy. These canceled. So what we really have left is like x minus 2 over x minus 3. And I am looking for the limit as x approaches 3 from the left. So vertical asymptotes can look 3 ways. You might get, hold on, green is better. You might, that's green, right? Yeah. So you might get like they both go up forever. So the limit from the right is infinity, the limit from the left is infinity. The overall limit, because they match, you could say infinity, those go up forever. You might get the opposite, where it goes like this. So down forever. So for both sides it goes down forever. And you might get, it could look either way, but you might get like that and that. Or the opposite quadrants, like this and this. And then in this case, the limit doesn't exist, because from one side we're going up forever, and from one side we're going down forever. Someone built this bridge, wasn't it? It was Busso, like I had to build a bridge, and he just kind of wandered off into space. So he was a vertical asymptote. And if the other side wanders off into space also, they match, and that's your limit. But if the other side wanders into the other space, like the other side, then it doesn't match, the limit doesn't exist. So we have to check this from both sides, and it's one of those like kind of fake math things again. So I'm going to check 3 from the left. So give me a number that is just to the left of 3. 2.99. So I'm going to plug in 2.9. We got it now. I'm going to plug in 2.99. And that will give me 0.99 over negative 0.01. Carter, what's up? I just don't have that much room. It's not like I'm breathing. It's not killing her. So, go ahead and type that into your calculator. Or, I don't know, you can probably do it now. What's 0.99 divided by 0.01? No, we're negative actually.
Wouldn't it be 3?
It's negative 99, isn't it?
Yes.
Agree? So the idea is that the x value is going to get closer and closer to 3. So let's make it a little bit closer and see what happens. So let's use 2.999. Well, that would make the top 2.999 minus 2, which would be 0.999. And that would make the bottom negative 0.01. No, sorry, 0.001. Divide that, and what do you get? Just move the decimal over 3 spots. Not the same.
Oh. 999.
Negative 999.
Or negative.
So then if I do one more, I'm kind of running out of room here. But let's say I do 2.9999, so 4 9s. The top would now be 0.9999.
9999.
The bottom would be negative 0.000001. And if I divide those, I get negative 9999.
So it would just be like.
Well, as I get, and I'm not even like in calculus, I'm not really close to the 3 yet. So if I did 2.99999 and just kept going, what's going to happen to this number? Careful, not infinity. Well, negative infinity, because there's a negative sign, that's all. But your idea is right. It's just going to get smaller and smaller and smaller, like more and more and more negative. So the answer to that one is negative infinity. So that's this scenario, where as you approach that, it goes down forever. So it might be this one or this one, but as I'm coming from the left, it goes down forever. So this guy is negative infinity. The closer you get to 3, your number's just going to get smaller and smaller and smaller, more and more and more negative. So now from the right, so let's say I plug in like let's just do 3.1. 3.1 minus 2 over 3.1 minus 3. Well, that's 0.9 over 0.1, which gives me 9. I'm not done. Like, I can get a lot closer to 3 than that. I'm just trying to show you the pattern of what happens as it goes. So let's say 3.01. 3.01 minus 2 over 3.01 minus 3. So 0.99 over 0.01. So what's that? 99. If I added another 0, I would get 999. If I added another 0, I would get 99. You know what I mean? It's just going to keep going. So as x gets closer and closer and closer to 3, this one's going to be positive infinity. Will? Oh, well, okay. You're right, I can't subtract. It doesn't change the point I'm trying to make, but it does change the answer. So you're right, this is 1.1, right? Divided by 0.1, so that's actually 11. This would be 1.01 over 0.01, which is 101. But the idea is the same. As I get closer, what's going to keep happening to this number? It's going to to get bigger and bigger. So that tells me that we're heading towards a positive infinity. And so I'm surprised it doesn't ask this, but if I said, what's the limit as x approaches 3, just like in general, what would you say? Does that exist because it's different from each side, right? Questions on that kind of fuzzy math? All right, let's look at 4. So I can tell there's going to be a vertical asymptote because there's like those wouldn't cancel, or there's a spot where the bottom equals 0 and the top doesn't. So where is there a vertical asymptote, first of all? At x equals 3. So x equals 3 is a vertical asymptote. If you have a vertical asymptote, your limit is either going to be positive or negative infinity. It has to be one of the two. Because if there's like a vertical, it's like a wall, and you're getting closer and closer to that wall, like you either get shoved up or you get shoved down. You can't just keep going through. It's,
Or you die.
I don't know if that's really an option in here.
Exactly.
But-
So you gotta go up and down.
Yeah, you gotta go up or down. Okay, so this is saying plug in a number very close to 3, but from the positive side, so just a little bit bigger than 3. So you get 1 minus, let's say, 3.001 over 3.001 minus 3. So that is negative 2.001 over 0.001. But that's not my answer, it's just like an example that I can use to get to the answer. So this would be negative 2001, if I work that out. I don't really care about that specific number, I care about what kind of pattern I'm going to see. If I made this 3.0001, I'm going to putting an extra 0. So now it's negative 2.00001. Will, am I subtracting better? He's like, you're okay. Now I get 200,001. So as I get closer and closer and closer to 3, what is going to happen to this number? It's going to get closer and closer and closer to negative infinity. Good. Do you want to try 4? Or 5, I mean? Try 5. I mean, I'll do it, but try it first. when you check a limit, you have to check from both sides. So like in number 4, they told you check from the right. In number 5, they're just saying like in general, so you should check one from the right and one from the left.
No, I know.
Well, like because you know you're actually checking both sides. Right? You consider both sides. Okay. So if I plug in like 1.01, so that'd be from the right. So let's say limit as x approaches 1 from the right. I would get say 1.01 minus 3 over, and it might be easier to write this as squared, because when I see the squared, it just jumps out at me like the bottom is always going to be positive, right? A negative number squared is a positive number squared is a positive, so the bottom's always positive. So you'll have like negative. Shut up, Will. I got it. Negative what he was about to tell me I subtracted wrong. Okay. So I get negative 1.99 over 0.01 squared. So I don't really care what that is. If I take 0.01 and multiply it by itself, does it get bigger or smaller? Smaller. So at the end, eventually you just start going like, okay, negative 1.99 over tiny. So what's negative 1.99 divided by 0.000, like a super small number, would be negative infinity, right? And then tomorrow we kind of get into the opposite. A tiny divided by a gigantic. So like what's 0.01 divided by infinity? It's 0. So that's tomorrow. So from the right-hand side, we get negative infinity. We need to check from the left-hand side also, because we're thorough. So that would be like 0.99 minus 3 over the same thing. Well, the top is still negative, right? It's like a different number, so now it's negative 2.01 over whatever. So you get a big number divided by a tiny number. That's infinity. And it's negative because of that negative sign. So those are both negative infinity, so your overall answer is negative infinity. But it's easy to forget to check for both sides. And it didn't matter in that one, but sometimes it does.
Where you messed up
Where?
with 1.01
Right.
So it would mean it does not.
So, crap.
Yes, goes.
No, it's still, that's going to be negative, but then you're going to square it.
Oh,
So it's still positive. But you're right, I put the wrong thing there. It just doesn't actually change the answer. I just got lucky. Question on those? Alright, let's have you guys start working and see how it goes. If you get stuck, let me know. I can do more on the board, I can do more help you, whichever. Yeah, there's a couple you're skipping, I think. Don't worry about 7, 8, or 18. You can skip 7, 8, and 18.